Hello learners, welcome to today's discussion. Today we are going to look at a subtopic, solubility, and solubility can be defined as the maximum number of grams of a solute that can dissolve in 100 grams of water at a particular or at a given temperature. The maximum number of grams of a solute. Remember, a solute is a solid that dissolves in a solvent. So let us look at the given question. The question we have reads, a group of Form 4 students of Kokelbet Secondary School carried out an experiment to determine the solubility of potassium chlorate. The table below shows the results obtained. We have the total volume of water added in centimeter cubic. We have the mass of the solute, which is potassium chlorate, the temperature at which crystals appear, and then the solubility of potassium chlorate in grams per 100 grams of water. And that is the area that we are supposed to work on first. Part A, complete the table to show the solubility of potassium chlorate at different temperatures. We have the mass of the solute, and at 80 degrees Celsius, 5 grams of potassium chlorate dissolves in 10 centimeter cubic. So we can say 5 grams of potassium chlorate dissolves in 10 centimeter cubic at 80 degrees Celsius. Remember, solubility is the maximum number of grams of the solute that can dissolve in 100 grams, and 100 grams means 100 centimeter cubic of water. In this case now, if 5 grams dissolves in 10 centimeter cubic, what mass can 100 centimeter cubic dissolve at the same temperature? So if you cross multiply, we are going to have 100 times 5, you divide by 10, and this one is going to give us 50 grams. Next, we have 5 grams dissolving in 20 at 65 degrees Celsius. So if 5 grams dissolves in 20 centimeter cubic, what about in 100 centimeter cubic? If you cross multiply, we are going to have 100. You multiply by 5, you divide by 20, and this one gives us 25 grams. From there, we have 5 grams dissolving in 30 centimeter cubic. What about in 100 centimeter cubic? So in 100, we are going to have 100, you multiply by 5, you divide by 30, and this one is going to give us 16.7 grams. Next, we have 5 grams dissolving in 40 centimeter cubic. So we have to find out the number of grams that we dissolve in 100 centimeter cubic at 45 degrees Celsius. So if you cross multiply, we are going to have 100 times 5 divided by 40, and this one is going to give us 12.5 grams. And lastly, we have 5 grams dissolving in 50 centimeter cubic. What about in 100 centimeter cubic? In this case, if you cross multiply, we are going to have 100 times 5, everything divided by 50, and this one gives us 10 grams. So we can now take these values and use them to fill the table. Because of the consistency of the decimal points, this is 50 grams, which is going to be 50.0. 25 will be written as 25.0. Then 16.7 is already to one decimal place. We have 12.5. And lastly, we have 10.0 grams. And by so doing, you would have now worked on this particular part very, very well. We move to part B. And part B is where we are supposed to plot a graph of mass of potassium chlorate per 100 grams of water against temperature at which crystals form. In this case, if you look at our graph, it is the mass on the vertical axis against the temperature on the horizontal axis. Let us have our graph paper here. So let us now have our graph paper, then try to plot this particular graph. In this case, I have decided to transfer the values that we are going to use here. We have the temperature on the horizontal axis. We have the solubility on the vertical axis. This is a graph of the mass of potassium chlorate in 100 grams of water against temperature in degrees Celsius. So we now go ahead and do the plotting. At 80 degrees Celsius, we have a mass of 50. At 80, we just move along this until we see 50 on the vertical axis, and this is our first point of the graph. Then at 65 degrees Celsius, we have a mass of 25. 65 is here, so we move along this line. This is 20. 25 is here. Then at 55, we have 16.5. 55 is here. So this is 10. This is 15, 16, 16. Then we have at 45 degrees Celsius, we have 12.5. 45 is here, we have 12.5. This is 10, 11, 12, 12.5 is here. Then lastly, at 30 degrees Celsius, the mass is actually 10 grams. Having plotted all these points, we can now join all the plotted points like this, and that is our graph so far. We are going to use the graph to solve the questions that we have. So let us proceed. This is part B of the same question. Told from the graph, determine the solubility of potassium chlorate at 40 degrees Celsius. So we come to 40 degrees Celsius. This is the temperature, so this is where we have 40. Just come and draw a broken line towards the curve. Then you join it towards the point where we are going to have our solubility. And clearly, as you can see, The solubility is about 12 grams in 100 grams of water. So in this case, the solubility is going to be 12 grams per 100 grams of water. The next part that we have, it is the temperature at which the solubility is 35 grams per 100 grams of water. So we are going to look at 35 grams, then we read the temperature at this mass. So you go to the graph once again. This is our graph. We have 35 grams. At 35 grams, you draw a broken line to show how you are going to pick your answer here. This is what we have. Then you come down like this. You come down like this. So you read off the temperature at this particular point, and the temperature is exactly 72 degrees Celsius. That is according to my graph. So you come here. The temperature at this particular point is going to be 72.0 degrees Celsius. D. Explain the shape of the graph. If you look at this graph, you realize as the temperature is increasing, the solubility of potassium chlorate also increases. That means with the increase in temperature, we have more potassium chlorate dissolving. Solubility of potassium chlorate increases with increase in temperature, or with increase in temperature, or we can also say more potassium chlorate dissolves as temperature increases. Any of the two answers is appropriate. Then the last part of this question, state one application of solubility and solubility curves or graphs. One of the uses of the knowledge of solubility is that it can be used to extract, that is extraction of common salt from seawater. Number 2, extraction of soda ash. This is sodium carbonate from trona. Trona is a double salt of sodium carbonate, sodium hydrogen carbonate. Thank you for watching and welcome to our channel. And in case you have just come across this channel for the first time, kindly take 1 second and click the subscribe button. And in case you have questions regarding this particular section, kindly reach us through the comment section, and we shall be glad to address your concerns accordingly.